Hi, you guys. We're on page 136 in the binder today for this video, and we're going to talk about scatter plots and lines of best fit. Okay, you guys have seen a scatter plot before, and there's a couple examples of them on this page. And then sometimes when you draw a scatter plot, sometimes the randomness of the points actually turns into sort of a pattern. Okay, and one of the patterns that the points can have, we call a positive correlation. Right, and what that looks like is that the points are trending in an upward direction. So they don't make a perfect straight line, but as x gets bigger, so does y. So we notice that as we move along the x-axis to the right, the points are moving in an upward direction. That's a positive correlation. It's just like a positive slope. Okay, a negative correlation is just like a negative slope. So in a negative correlation, as the x values get bigger, the y values tend to get smaller. Okay, and so that's the same situation here. X is increasing, y is decreasing. All right, and finally, then if there's no correlation, where it's not positive or negative, the points are just kind of spread randomly about, and there's no specific pattern upwards or downwards. Okay, that's a no correlation example. Okay, so if we look at example 2 here, we see a graph that shows the connection between hours of studying and test scores. Right, a couple vocab words to remember: hours of studying, the x-axis is the independent variable, independent, and the y-axis is the dependent variable. So what we see is that as hours of studying increases, the test scores increase. Okay, so this graph shows a positive correlation. And we just kind of said this: as the hours of studying increase, the test scores increase. That's what a positive correlation means. As x increases, y increases. Right? So can you come up with another example of positive correlation? One that I like is that as the temperature increases, then ice cream sales increase. Right? So as it gets warmer outside, more ice cream is going to be sold because people are more interested in buying ice cream when it's warm out. Okay. Our second graph here has a comparison between hours of television watched and the test scores. Okay, so now instead of studying, we're spending our time watching television, and those test scores are going down. Okay, so this graph shows a negative correlation. All right, meaning as the hours of watching TV increase, so hours of TV is going up, test scores are going down, so they're decreasing. Right? And what you want to remember, what's really important to remember about these scatter plots, is this isn't one person who is studying and it says if you study for 4 hours, that your score is going to be 80%. No, remember, each of these data points represents someone that they took data from. So there's someone out there who studied for 3 hours and got a score of about 81 on the test. Or, excuse me, watched 3 hours of television. There's another person out there that watched 6 hours of television and got a 68% on the test. Okay? So these data points represent individual responses to a survey, potentially. Okay? All right, so an example of negative correlation, that could be something like as the amount of snow on the ground, increases, then the number of drivers on the road decreases, right? As it becomes more and more snowy outside, fewer and fewer people are going to drive. All right, here we go in example 3. All right, example 3, determine whether the following scenarios describe positive, negative, or no correlation. So the temperature and winter coat sales. So as temperature goes up, so this is your independent variable. As temperature increases, winter coat sales those are going to decrease. Okay, they go in opposite directions, so that's negative. All right, if they go opposite directions, it's negative. So your age and your height. Typically, for most of your life, until you start to get old and maybe shrink a little bit, as your age goes up, your height also goes up. So that's a positive correlation. Right. Especially if you're talking about basically your age from 0 to about 18. Once you stop growing, then it's really flat. There is no increase anymore. All right, and the age of the car and its value. Well, use the table below. All right, so as the car increases in age, the Y value, the value of the car is decreasing, so that's negative. All right, let's flip to the next page. All right, at the top, you'll see a nice little summary about how to create a scatter plot. And so if we look through that, you know, you want to choose an appropriate scale based on the data that you have, plot the data points, and then we're going to draw a best fit line. So when we're doing this by hand, we can just kind of estimate, and you can see on this page in example 4 an example of a best fit line. Okay, sometimes it's known as a trend line. Later on in this chapter, we're going to learn it's called a regression line. But the idea is it's kind of supposed to split the data in half. All right, so half the data is above the line, half of the data is below the line. All right, we can, using that line, then estimate the y-intercept, estimate the slope, and use that line to make predictions. So the data helps us make predictions about what might happen in this situation here. Okay, so example 4, does the trend line show a correlation? All right, well, it does, because as the hours of exercise increase, the resting heart rate decreases. Okay, and so yes, it does show a correlation, and it's negative. All right, so now it says write an equation that models the resting heart rate. So we need to estimate the slope and the y-intercept, right? Well, the y-intercept is pretty easy. It's just about 80. It kind of looks, if you look real detailed there, it looks like it's a little less than 80. So I might say 79. Okay, so my y-intercept is 79, and now the slope, all right, let's see if we can find any really nice points to grab here. Here's one. That's a good point. All right, and you know, we should probably just use our y-intercept too. Okay, so again, we set our y-intercept to 79. So when I'm doing my rise and run here, I'm going to go from 79 to 55. So my rise is negative 24 over, and then I make sure you're looking at your units here and not actually counting. So I went from 79 to 55. I didn't go down 1, 2, 3, 4, 5 because there's 5 tick marks. I actually had to count the units there. Right, and then exercise hours, I went up 6. So negative 24 over 6. Oh, that's kind of nice. That's the number negative 4. Now, when we write an equation for a word problem, we're going to do it in the context of the problem, okay? And so instead of y, I'm going to call it heart rate, all right? And so we do heart rate equals, all right? But there's this fancy symbol we're going to use, and we want to get used to using this. So it's not really that fancy. We put a little, looks like a roof over heart rate. We call it a hat, actually. So what that means is it's predicted. Predicted heart rate is how we read that. So predicted heart rate equals my slope, which was negative 4, times, what's the x value? It's hours of exercise. So exercise, we'll just call it exercise, plus the y-intercept, 79. Okay, so predicted heart rate was negative 4 times the hours of exercise plus 79. All right, now in this problem, the slope represents a rate of change. Okay, So we want to think of it with units. So -4, and you put it over 1. My y unit goes on top. Remember, slope is always y over x. So my y unit goes on top. It's beats per minute. Beats per minute. And on the bottom is hours of exercise. Okay, so the way we say this is we say that for every hour of exercise, we have to use the word predicted. Predicted beats per minute decreases by 4. Okay, so that's how we interpret the slope. So we say for every one of the x value, so for every 1 hour of exercise, and then the y value, we're using this data to predict. So we have to say the predicted beats per minute decreases by 4. Okay. All right, and then explain what the y-intercept represents in this problem. So the y-intercept was 0,79. All right, and so we just say at the x value of 0. So at 0 hours of exercise, predicted beats per minute is 79. Okay, I think that's enough for this video. You've got one more problem at the bottom that you could try out, where you make your own data, what is it, scatter plot? You make your own scatter plot and trend line, and then interpret your own slope and intercept. Don't worry, we are going to practice a lot of this in class. Okay, have a nice weekend. Thanks for watching.